In this game, collisions between elements are an essential factor. We need them to detect when the laser hits the target, reduce energy, and calculate what happens from the action standpoint. However, for us to conveniently test the collisions, we will need more elements. For this, we will proceed with the basic construction of the elements just to ensure their existence. Once all are in place, we will add the necessary components to handle collisions. However, before all that, in level 1 we can remove the script learn, as it was only used to demonstrate the script's structure, and from now on it's no longer necessary, if you still have it. Each game element will be a scene as we have done before. Thus, we will create a new scene based on Node2D named Alien1 and save it under the same name in Elements. Alien1 will have a sprite2D to house the texture, which should have a region limited to the body of Alien1. Like the player laser, the alien will move on its own and will need to be removed from the game after leaving the screen. For this, the node visible on-screen notifier 2D is necessary. Don't forget that the area set in this node is the area that will be used to calculate if the node is still on the screen, so it has to cover the entire sprite. For movement, we will need a script inherited from Node2D, which we will name Alien. The goal is to program a versatile script with the ability to be used for all the aliens, even if they have different behaviors. For this, we will have to declare variables to configure in Godot and make the code as generic as possible. We declare a variable for speed and another for the direction of movement. In the process method, we increment the position with the movement multiplied by speed and the duration of the frame, delta. After saving everything, if we add the Alien1 scene to the level 1 and run the game, we should see the alien moving downwards. Let's continue and build the other aliens using the same process. For the others, we won't create more scripts, just use the same alien.cs. In fact, we go to Alien1, select all the nodes and copy with Ctrl+C. In the new scene, instead of choosing to this scene, we click on Paste from Clipboard, and the entire structure will appear as in Alien1. We just need to change the names and select a different region in the sprite. Don't forget to save in Elements as Alien2. The same applies to the alien boss. On testing all elements in level 1, we can see that they all behave the same. However, if we change the speed variable for each one, using the same script, we get different speeds, because each one replaces the variable value with the value we put in the inspector, with the latter prevailing and being applied to the script. We must be careful with one detail. When a variable can be changed in the inspector, the topmost inspector, in terms of the node tree structure, will prevail. For instance, setting the player's speed to 3500 does not affect the final speed of the element, because in level 1 scene, there's another manual configuration with another value. We know this because we can see the button to reset the original value. Therefore, it is good practice to change this value only in one place, for instance, always in the original scene, and never in the following scenes, to avoid losing track of where parameters are set. The cannon and laser of the aliens are similar to the players. The main difference lies in the direction of movement, the target they attack, and how to trigger them. To create the alien laser, we can simply copy the player laser, but we will need to modify the script that controls it, since the movement will be in the opposite direction. The result will be a script identical to the player laser, but with the vector inverted. As duplicating code just to change a variable doesn't make any sense, we can instead create a more versatile laser script that can be used on all lasers. For this, we create a script named laser based on Node2D and copy the entire class from player laser. But in this case, we export the vector to movement, so we can modify it in the inspector, and we leave it the value at 0, 0 by default. We add and replace the script in the respective nodes. In alien laser, we set y to 1, and in player laser, we set the y to -1. This way, the same script works for everyone, and we don't need to write duplicates. Once we replace the script in player laser, we can delete the player laser script. Be careful, don't mistakenly delete the scene. You want to delete the player laser.cs. At this point, both lasers should move in the correct direction. We create a script to govern the alien cannons. We start with a basic one that fires every half second. Create a scene and a script named alien cannon and integrate them. Like the player cannon, a variable will be needed to house the laser. To allow it to fire repeatedly every half a second, we have to keep track of the time and check if the waiting time has passed. We use one variable for the wait time value and another to count the elapsed time. In the process method, we already have a counter working. Remember that delta is the time the last frame lasts. If in each frame we add the delta value, what we get is the time passing in seconds. Thus, we just need to compare the counter with the wait time, and whenever it is equal or greater, we fire a laser and reset the counter to 0 for another count. We add the alien laser to the variable in the alien cannon inspector and save. Then, in each alien, we place the cannons wherever we find them visually appealing. Let's not forget to arrange all these elements in depth. With a player always needing to be above, we set the z-index to 100. We should turn off the relative option for all of them. The player laser goes 90 to be below the player, but above the aliens. The alien boss is at 50, alien 1 at 40, and alien 2 at 30. The alien laser is at 20 to be behind all elements. We are using tens to safeguard some space between them, in case, later on, other elements arise that need to be interpolated. To process collisions between these elements, we need to define an area for each element as if it was the body of the object. Let's start with a player. We add an Area2D node directly to the root node. For this to work, this node requires a shape that defines its form. In the Area2D node, we add a collision polygon 2D. This, in turn, needs to be configured to provide the shape of the Area2D. With the node selected, we click around the sprite to define its shape, but without getting too detailed. A rough outline with the basic shape is enough for the type of game we are building. We should do the same for all other elements that appear in the image, such as the aliens and the lasers. For lasers, we can simplify even more and save processing by using a collision shape configured for a rectangle shape. Only the top needs to have collision. We can copy from the player, but then we need to reset the polygon to redraw the correct shape. Each element should be identified. We can do this with collision layers and mask. Simply put, the element is in a layer and collides with what's in the mask, but collisions are identified based on the layer number, and this can be confusing. In Godot, there's another way to detect who you collide with. We can assign groups to elements and, in a script, check if the collision happens with the element of the group. The difference is that we can call groups by name, making programming and configuration easier and more understandable. So we select the root node of the player, and in the Node tab, next to the inspector, we can see the node's signal and configure the groups it belongs to. In this case, we set it as player. The aliens will be configured as enemy. Notice we have a new icon next to the node. This square with a circle in the middle indicates that this node has one or more groups set. Now that we have all elements with the required components and grouped correctly, we can go to the laser script to program the logic that will handle the impact. In the laser script, we start by declaring a string variable for the group name to attack, so that we can configure both the players and the aliens laser differently. We create a method to act at the moment of collision. The method will require an Area2D type argument because when the collision happens, a signal is sent containing the Area2D with which it collided. In the ready method, we link the Area2D's area entered signal to the new method. We will use this Area2D to check if it is the correct group and act accordingly. However, when we verify the group of the other, the one we collide with, we won't get the expected answer because it is the parent that is in the group. It's the root node, not the Area2D. So we need to go down the tree to check the parent's group, hence the use of getParent. If the group is the same as described in the variable, the code will continue within this if. For now, we add a print to mark the operation success and go to Godot to set up the variables. In Godot, we click on Build, and in Alien Laser, we set Player. And in Player Laser, we set Enemy. This way, every laser knows what to attack. When running the game, we will see a print for each collision, from both the players and the aliens' side. Now we only need to destroy the element, and for the lasers it's easy. Whenever a collision is valid, we destroy the laser. Since the collision detection occurs within the laser itself, simply adding remove element within the if statement will activate the method that removes the laser. As we can see, lasers that hit the correct targets are removed from the game. Regarding the destruction of the spacecraft, the system can be simple as this, just sending the other parent to the cure-free, but this wouldn't forgive a single accurate shot. Since we are no longer in the ruthless 80s, where the players died desperately and restart the game from the beginning, we are going to create a more complex system. The mechanics of the system will be as follows. Each element will have a script called health. In health, we have a value related to the energy of the element, whether it is the player or the alien, and two methods. one to increase the value and another to decrease and destroy. Whenever a laser collides with a valid target, what we are already doing within the if statement of the laser will search within the target for the health script and activate the method that reduces energy. This method also checks if the energy reaches 0, and if so, will remove the element. This will make all elements autonomous in managing their existence, simplifying elements management, especially when aliens are instantiated randomly. We create a script called elf, inherit from node2D. In the root node of the player, we add a node2D, also named elf, and add the script. We don't need the process method, so we can delete it. We declare two variables to work with the health value of the element, one int name health, which we will use to calculate the value, and a public int named max health to configure the node and limit in cases of increase. Next, we create two methods, one to increase the energy and another to decrease and destroy the element. For increasing, we create the increase health method with an int argument, which will be the increase amount. The calculation is simple. Health is incremented by the value of value. And then we check if health hasn't exceeded the max health. If it has, we ensure that health is set to max health. For decreasing, we create a decreasing health method, also with an argument for the decrease amount. This does the opposite calculation, subtracting the value. However, in this check, it verifies if the value is below or equal to 0. If so, it implies that the life of the element has ended and it should be removed. Inside this check, we have the command to remove the element. Sounds simple, right? Not really. If we remove the code here, as it is in the code, what will disappear will be the health node, not the alien or any other object. This script is in the health node, but we won't remove the parent, the root node of the element. For this, we need a reference to the root node. We declare a variable of type node2D named main node. In the ready method, which is when the element appears in the game, we search for the root node and add it to the main node variable. Now, main node is a reference to the root node. And if we execute QF3 on main node, we are actually making the parent disappear and consequently the entire element. This ensures the self-sufficiency of the element, but we still need to get the laser to discharge values into decrease health. In the laser script, we start by declaring an int variable for the value that the laser deducts upon impact. Whenever we have a valid collision, we declare a variable of type health, our other script, named other health, and we assign the health node of the other element. For instance, if our laser collides with an alien, other will be the Area2D of the alien, from which we need to find the parent node that has a child named health. Once this node is associated with the other health variable, we can work directly within the health of the target element, using other health as a reference. Thus, we instruct the decrease health method of the other element to execute, and since decrease health expects an int value, we give it the value of the laser power. In summary, whenever a laser hits a valid target, it searches for the health and instructs it to decrease the value based on its own power. In Godot, we need to ensure that all aliens and the player have the health node. We can copy it from the player. We can also give the player's laser more power than the aliens. Running the game, we can see that the system works, and it's easier for the player to destroy aliens than for an alien to destroy the player. Copy the entire content of this lesson. Create the bomb and health pack elements. Make the health pack, when picked up by the player, increase the player's energy. Make the bomb, when it touches the player or alien, destroy the element immediately.